Hello students, welcome to Educate. We are going to continue with chapter 6 of class 12 physics. So in previous lecture, we have studied about mutual inductance. Today, we are going to start from self-inductance. So self-inductance is denoted as L, and suppose this is a coil, then its self inductance will be L, whose unit will be Henry, represented as H, right? So if there are n turns in a coil, and suppose here there is a source and this is key, suppose key is open, and when this key is closed, then what will happen? Current will start flowing in this direction, then an induced current will flow in this direction, or there will be an induced EMF, right? So first of all, we have to check that what is the number of flux, and after that we will find out the expression for EMF. So flux will be number of turns times flux connected to each turn. Suppose it is phi b, and phi b will be proportional to current flowing through the coil. So here we put a constant. So we write n phi b equal to Li, where L is coefficient of self-induction, as I have told you in the beginning. Now EMF induced is equal to minus d phi by dt. Here total flux is n d phi. So minus n phi b by dt, which will give minus L di by dt. Here I is change in current and dt is change in time. So this is basic expression. Now we can also find, if you remember, B inside a solenoid is equal to mu naught Ni, right? So here we can apply the formula again to get L by another way. So I am erasing this portion. So to consider the number of flux, we can use the concept like, here we are taking that suppose length of solenoid is L and area of each section is A, and there are n turns, then magnetic field due to current I flowing in the solenoid is given by B equal to mu naught Ni, as I have told you earlier also. So B will be equal to mu naught Ni, right? And we need flux. So number of turns phi equal to BA, right? So B is here. So total flux is N phi B equal to magnetic field mu naught Ni, right, into area is A, and suppose, as I told you, that L is length of solenoid, suppose the solenoid, and number of turns per unit length is small n. In that case, here total flux will get multiplied by that number also. So n into L, right? L is length of solenoid, number of turns per unit length is small l. So this will be total flux. So we can further simplify. Here n will get squared. So it will become mu naught n square A L times I. So this is n phi b, right? And previous relation, do you remember? So previous relation was n phi is equal to Li. So suppose this is equation number 1, this is equation number 2. If you compare the two, you can get the value of L. So L will be equal to mu naught n square A times L. If you wish, you can write small n equal to capital N upon L, then you will get another expression, right? And if inside the solenoid there is some material, if you put, whose permeability is mu r, in that case L will be multiplied by this mu r. So our relation will be mu r mu 0 n square al. This is an important expression that you have to understand, is you have to practice this so that you can derive this result. Generally in CBSE exam this question is asked. Now let's find out another concept, that is energy stored in an inductor, and after that we will do one numerical. We can read this here. There is some more information. Up to here we have reached this point. The self inductance of the coil depends on its geometry and on the permeability of the medium, as it is clear from here. Number of turns, geometry means number of turns, area of cross section, length, and here material inside. Now the self inductance EMF is also called the back EMF, as it opposes any change in the current in the circuit. As you have seen that here, if we consider this circuit, this is key. So if current flows, if this key is closed, in that case current will flow in this direction, then EMF developed across this coil will oppose it. So there will be another current which will oppose this, correct? Or EMF developed will be just opposite. If this has positive and negative polarity, this will be just opposite, negative and positive polarity. So that is why this is called back EMF, right? Physically, the self-inductance plays the role of what role? Like inertia in here, the role of inertia, right? It is the electromagnetic analog of mass in mechanics. So work needs to be done against the back EMF in establishing the current. This work done is stored as magnetic potential energy, right? So work done is stored in form of magnetic potential energy. So rate of doing work is dw by dt, which is power, if you remember. So V into I, you have already studied that power is voltage into current. The same thing is written here, dw by dt is equal to voltage written as EMF. Here modulus tells that since E is minus L di by dt, here we are taking its modulus value EI, right? So suppose we want to find out energy, then we can further do it. So if we ignore the resistive losses and consider only inductive effect, then what we can write? In place of E, E is L di by dt. So here, if we further write, so we will reach here dw by dt. In place of E, there is I already, and L di by dt, right? And then we can remove dt from both sides. We will get dw equal to I di by dt times L, right? And then if we integrate it, integration will give this LHS will become W, and here L is constant, and so we can keep it outside. Integration 0 to here, current is being changed. So suppose we write value of current from 0 to I0, highest value, then I di, right? Here dt is already removed, so dt will not be there. And if you remember integration x dx, that gives x square by 2. So this will become L this will become I square by 2, and then we put the limits 0 to I0. So this will give L times I0 square divided by 2, which is energy stored in inductor. So here this expression W equal to L I square divided by 2 is the energy stored. This is equivalent to kinetic energy like half mv square. If you compare this, if we write that energy stored in inductor is say U equal to half L I0 square. This is similar to energy, if you remember, half mv square. So here L plays the same role as that of mass, right? So this is electrical analog. Now we can move further. Here we are going to consider the general case. So consider the general case of currents flowing simultaneously in nearby coils. Suppose there are two coils. We are going to consider this situation that this is one coil and this is another coil, right? And here it has current source also like this, right? This contains suppose galvanometer. Then what happens when switch will be closed? Then current will start flowing here. Then flux linked with this coil will change. So that thing we are going to discuss here. But here, since there are two coils, so mutual inductance will also be there. So now consider the general case of currents flowing simultaneously in two nearby coils. Here they are saying that here this also contains battery and current flows in it. So it's simple. This was general case of mutual inductance. They are saying that both coils are having source and currents are flowing in. In that case, what will happen? So when current will flow through this, so here flux change will occur due to its own effect, and when current flows in this, then again flux will change in it due to effect of second coil. So here we have to take into consideration the two cases. One is mutual inductance, another self inductance. So expression will be like this: N1 phi 1 means flux change, total flux, N1 phi 1 equal to M11. M11 means when current is flowing in this and there is change in flux, right? So for the same coil, so later on M11 will be written as L, right? Or L of first coil, then I1 plus M12, here this is mutual inductance of the two, and I2 current. The same thing is given here. So we can say, if you remember formula, E equal to minus L di by dt, and if M is given, then M will also be there. So if we write it as EMF, then E1 equal to minus M11 di1 by dt minus M12 di2 by dt. Is it clear? So here M11 is the self inductance and is written as L1 of first coil. The same case is true if you consider for second coil. So it is written as E1 equal to minus L1 di by dt minus M12 di2 by dt. I think this is clear. Now we are going to see an important question. Here question says, obtain the expression for the magnetic energy stored in a solenoid in terms of magnetic field B, area A, and length of L of the solenoid. How does this magnetic energy compare with the electrostatic energy stored in a capacitor? Do you remember the formula of energy stored in a capacitor? It is half CV square, where Q equal to CV. So in other forms also we can write it. So magnetic energy, as we have just derived, half Li square. Here we are assuming that I is the maximum current, and if you remember, B equal to mu naught Ni, and here we have used Li square. So I we can get from here, I equal to B upon mu naught N. So that value we write here. So 1 by 2L B square upon mu naught square N square. And then we can get the relation 1 by 2. Value of L we have already derived that L is given by L means coefficient of self induction. So mu naught N square AL, and then value of B is B upon mu naught N whole square. We simplify it. So 1 upon 2 mu naught B square AL. Why? I think you have understood. Just simplify it, you will get this thing. And then, so now we are going to evaluate energy stored per unit volume. So per unit volume means you have to divide by volume. So here AL, area into length, will give volume. So just divide it. So you will be left with B square upon 2 mu naught. Up to here there is no problem. We have already obtained the relation for the electrostatic energy stored per unit volume in case of capacitor, that was U equal to half epsilon naught E square, right? In both the cases, energy is proportional to the square of the field strength. Here, if you see this energy, here UB is proportional to B square. Here UE is proportional to E square. So the same thing is given. In both the cases, energy is proportional to the square of the field strength. Correct? So if you don't remember this, so I can make you remind of it. Energy stored U equal to half CV square, right? And if you remember, suppose these are two plates and separation is D, right? So electric field is given by what formula? Do you remember? E equal to V upon D, right? So here V you can replace by ED, right? So 1 by 2 C times E square D square, no problem. And capacitance C is given by epsilon naught A upon D, correct? You put this value also, and then assume AD equal to volume, and then find energy per unit volume. You will reach here. So you have understood. Now we are going to see next thing, that is AC generator. So here everything is explained. These are the poles of magnets, north pole, south pole. This is coil which rotates, and here there are slip rings, and these are outer connections. There are carbon brushes which remains in continuous contact with the slip rings. So construction you can read, so I'm not going to tell about it. Now our main concern is to get the expression of EMF induced. So flux phi B equal to BA cos theta, right? And theta is omega t. So phi B is BA cos omega t. If there are n turns, then this can be written as NBA cos omega t. So we find EMF E equal to, so we take absolute value, or if we don't take, then what will happen after differentiation? Minus sign will come and that will automatically cancel it. So let's write NBA n d phi by dt. So d upon dt of BA cos omega t. And you know, differentiation of cos theta gives minus sin theta. Here omega is also there. So d upon dx of cos ax gives minus a sin ax, right? So let's put that value here. So this will become, here minus sign is already there, so it will become plus n b a and then omega and sine omega t. So this is EMF. Now suppose we want maximum EMF. So E max will be this will become 1. So NBA omega. And suppose we want to find out the current, in that case we can divide it by resistance. So I think you have understood, and you know AC fluctuates like this, right? Up to here, this is positive, plus 1, this is sine curve, this is minus 1, this corresponds to minus 1. Sine theta curve, I think you remember, I'm drawing it systematically. So it will be like this, right? So in terms, suppose this is pi, this is 2 pi. In terms of time period also we can write this will be t by 2, this is t, like this. So that you can see in the diagram, you will understand, because it is very basic thing. Here the situations are shown. This is t by 4, 1/4 rotation of the coil. Then this, then what happens here? Coil will be perpendicular to the magnetic field, then it will further rotate, then it will be anti-parallel, and again it will go in another direction. So coil is moving like this. First it is like this, then it becomes like this, then it becomes like this, then again it goes like this. So rotation is shown. Then EMF, induced EMF, will fluctuate. It will become positive, then it will go negative. So that is why it has, whenever we talk about AC, we say that there is certain frequency, and generally it is around 50 hertz in India, but in US it is 60 hertz, right? Now we are going to see one numerical based on it. What does numerical say? So numerical is simple. Here question says, Kamala pedals a stationary bicycle. The pedals of the bicycle are attached to a 100 turn coil of area 0.10 meter square. The coil rotates at half a revolution per second, and it is placed in uniform magnetic field of 0.01 Tesla perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? So simple. We have seen that EMF is NBA omega, right? So here we need number of turns. So number of turns is given 100. Magnetic field is given as 0.01 Tesla into area of cross section is given as area of coil, not cross section. So 0.10, and times omega. Omega means 2 pi times frequency. So 2 pi into frequency is 0.5, right? So 2 into 3.14 into 0.5. Then evaluate it. It will come out to be 0.314 volt, correct? So lesson is over. Let's have a quick recap of the lesson, and after that we will do numericals. Here the magnetic flux through a surface of area A placed in uniform magnetic field B is defined as phi B equal to B dot A or BA cos theta, where theta is the angle between B and area vector, means perpendicular drawn on the area. Then comes Faraday's laws of induction. This implies that the EMF induced in a coil of n turns is directly related to the rate of change of flux, that is E is equal to minus n d phi by dt, where phi b is the flux linked with 1 turn of the coil. That is why n is used, since n turns are there. The current I is E divided by R. Then comes Lenz's law. Lenz's law states that the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces. The negative sign in the expression for Faraday's law indicates this fact. Then comes, when a metal rod, here we are talking about motional EMF. When a metal rod of length L is placed normal to a uniform magnetic field B and moved with a velocity V perpendicular to the field, then induced EMF called motional EMF is given by E equal to BLV. Then comes mutual induction. So inductance is the ratio of the flux linkage to the current. It is equal to N phi by I, that we have seen. If you remember, when we talk about this N phi proportional to I, or we say N phi equal to Li. So this is L is inductance. So L equal to N phi by I. The same thing is given there. A changing current in a coil 2 can induce an EMF in a nearby coil. This is relation is given by equal to minus M12 di2 by dt. Right? So here M12 is coefficient of mutual inductance. And we have already derived the result that M12 equal to M21. And then comes next thing. Next thing says, when current in a coil changes, it induces a back EMF in the same coil. The self-induced EMF is given by equal to minus del I by dt. L is the self-inductance of the coil. It is the measure of the inertia of the coil against the change of current through it. Then comes self-inductance expression. So if material of permeability mu r is put inside the coil, in that case, self-inductance becomes mu r times, that is given by L equal to mu r times mu 0 times n square times AL, where A is area of cross section of the solenoid and L is length and N is number of turns per unit length. Then comes AC generator, in which induced EMF is given by NBA omega sine omega t, right? And where we have assumed that at time t0 the coil is perpendicular to the field. So this is all. There are certain points that you can read, and now in next lecture we will do numericals. Thank you for watching. Team Educate.